The product is a what?
The product is a 1 by 1.
A 1 by 1. A 1 by 1, trust me. A 1 by 1. That's how I promoting how to do it. So if you want, you can read what the unit saying and try to do it that way, but that is the way I promote it. Therefore, the product is a 1 by 1. You can even write it in terms of words. I would penalize you, but 1 by 1. The product is a 1 by 1. Okay? So, how to multiply now? How to multiply matrices? So now we're ready to multiply. Let me copy it down. So we determine that yes, multiplication is possible, and our answer going to be a 1 by 1. How to multiply?
Yes, sir. Let me tell you.
Yes. Say it in your own words. Yeah, I'm listening.
You have to multiply -3 by -5 and -10.
Can you put that in terms of words, like you're making a general statement, apply to any matrix? What you are multiplying? Yeah, what you said is
Multiply the
correct.
first element.
So, but to me, he said -3 by -5 and -10. No, it's a 1 by 1.
Yeah, it's 1 by 1.
Okay, so
So
just
you
keep
have
that thought. Keep that thought. How to multiply?
so you do -3 by -5 and it plus.
But we correct, when you say and, you correct, because
Okay,
when you say and, what and is what?
is a plus.
So
Plus,
by saying and, you correct,
Okay, and it by -10.
Okay. So what you said you're correct. Let me just put that in words. To multiply matrices, you multiply the core, the elements. You multiply. There are different ways of saying, but let me look at another way. You multiply each element of the row of the first to its corresponding element, all right, in the column of the second. So that's why I maintain from the beginning, always row of the first and column of the second. So if you look at, there's a consistency now, in that whole language, row of the first and column of the second. So if you look at the notes that I formulated, it's always about row of the first and column of the second. So anytime you think about multiplication of matrices, let's go over it again. To determine if multiplication is possible, row of the first, column of the second. Elements in the row of the first, column of the second. To determine the size, number of row of the first, number of column of the second. And when you multiply now, is the same row of the first and column of the second. Okay, so there's a consistency in the analysis. But if you do it the other way, there's a little twist. You have to twist your mind and change it around. All right, but anytime you're thinking of multiplication of matrices, it's always a row of the first and column of the second. So when you're going to actually multiply now, you have to multiply each element of the row of the first to its corresponding element in the column of the second. All right. And then now to obtain one number, you add these products. All right, that's where you have the and, that's where you have the plus happening. You add these products. Okay, you must add those products after. When you see you multiply, you have to add the products. That's where you have the and. So say that again, Roberts, what you were saying again, what you said a while ago, or somebody else. How are we going to multiply those two matrices? Anybody?
I was saying, yeah,
Yeah, just repeat what you
negative
said.
3,
Just repeat what you said.
negative 3, negative 3 by negative 5.
Right. So isn't that what he's doing? He's multiplying -3 to -5. -3 is in the row of the first. It corresponds to the -5, which is in the column of the second. It is the first element in the row. So multiply to the first element in the column, isn't that so?
Yes.
And that's where the plus come in.
8
The 8 is the
times
second.
negative
The
10.
8 is the second element in the row of the first, isn't that so?
Yes.
Which corresponds to the who? In
The
general terms,
second
element
in the column.
of the second, you see. And then just to get one number, all right. I normally call it all right, I normally call it a product sum. So in other words, you are performing a product, because you have to multiply, a product sum operation. All right, product sum, product for multiply and sum for add. All right, you must multiply to get a product, and then you have to add to get a sum, a product sum. Okay, so here you're going to get the product. Look at what I'm going to write. So what I'm doing actually, you see, that's how the textbooks are created, you know. So you're all even contributing in the production of a textbook. That's why I don't I don't normally say look one by that book, because you can actually form the book as you're going along. A product sum, you have to product and then you have to sum. A product sum. So having said that, what to write there again now? Anybody? -3 what?
Times -5.
-3 times -5. Insert equation. I want to insert equation, right? -3 times -5. That's a product. Okay. What else?
Equals,
No, no, no,
was
no, no,
No,
no, no,
no,
no, no,
plus,
no, no. Not
plus. Remember,
equal,
it's
not equal.
and.
Plus. Okay.
Plus.
Right. So as you say that there now, let me just put the sign. That's why I need to know what you're thinking, because remember, this is a language and symbols. So think of product, think of times, and then when you're thinking about the sum, think about a plus. So no equal yet. No equal yet. A plus. Plus what? 8.
8 times negative 10.
8 times -10. Now you put the equal. No, 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 no. You don't put equal inside there, because the equal is implicit. You put the equal outside. Okay, now you put the equal. And what's the answer?
-55.
And what size of matrix is -55?
Negative
A one by
64.
one.
Negative 55 is a 1 by 1. Negative 55. Somebody saying negative 60. Negative 55 is a 1 by 1. One row, one column. And we already proved that. We're going to get a 1 by 1. There it is. 1 by 1. Now, what I'm
So it's
going to...
negative 65, not 55.
Oh, negative 65. That's why now, please don't just copy down the answer. Do it yourself. Make sure you have your calculators in hand. Please, everybody, you need that calculator for 115 and you need that calculator for university. Invest in a good calculator, and you know it's your good friend in a math class. Okay, because from now on it's calculator. All right, calculator use. So know how to use your calculator. Negative 65. Okay, so now we're going to accelerate a little bit. What's the time? Time up, man.
Yes.
Time up. Time up. Um I wanted to do another one like those there, but time is up, so we can leave that for next class. Yeah, I want to do one like but some people might have a class. I want to do one like those there.